Hello, future engineers, and today we are going to be going over practice 1 ladders in our parallel circuits. So parallel circuits mean that there are individual branches where we're going to distribute a voltage to them equally, and we're going to make some discoveries about this. So let's start by creating this circuit inside of Tinkercad. We've got a 15 volt power supply, and then we've got 3 different resistance values. And then we're going to be finding some values of all of our different properties of electricity, our resistance, our voltage, and our new one, amperage. All right, so let's go take a look over here. Inside of Tinkercad, I am going to start with my small breadboard. And instead of using a battery, I'm going to get out a power supply. So you're going to have to take a look for that. And I'm going to grab this power supply over here. Now, power supplies allow us to have any voltage that we want within reason. I think this one goes up to 36 volts, and that just gives us a little bit more adaptability. So I am going to set this to be 15 volts. You can leave the current as is. And all I'm going to do is connect my positive end here. I'm going to click to make a bend in my wire, and I'm going to connect my negative end over here. And you can also click and drag these to get these perfectly if you are like me and want that to be identical. So I'm going to switch this over to red so I know that I now have my positive in and my negative out. All right, now from our schematic over here, we can see that we have 3 resistors that are all connected to the voltage. So what I'm going to do very quickly is I'm going to grab resistors, and I'm going to grab 3 of them. I'm going to place one right here where it's coming out. I'm going to move down over here just so we have some space in between them. Grab another one and move this over here. So you can see that we've got all 3 of these popping out of our power and then out over here. Now we need each of these to return to negative. So what I'm going to do is I'm going to grab some black wires, and I'm going to have this row all go back to negative. And now that this row right here connects back to negative, I'm just going to grab all of these and link them back over there. It's going to be this nice little bar formation. It looks real pretty. All right, let's take a second just to review what I did, because I did that pretty quickly. We've got our power going into this power rail. Out of the power rail, we have got 3 different resistors. And out of those resistors, each of those has a wire that connects back to a shared negative port, and then it goes back into negative. So how I got here was I took a look at our schematic. Over here, you can see that we've got our power supply, and out we've got voltage going to resistor 1, and the same voltage going to resistor 2, and the same voltage going to resistor 3. All of these all go and connect to the same spot over here, and then back into the battery, which is exactly what we did. Now we need to set up all of our resistors to have the correct values. So we've got 470, 2.2K, and 3.3K. So let's go into our diagram over here. The first resistor was, I already forgot it, 470. There we go. But that one's just ohms, not kilo ohms. 470. The next one is going to be 2.2 kilo ohms. And the last one is 3.3 kilo ohms. Cool. Again, just like our first example that we went over in the last video tutorial, these are functioning circuits, but they don't really give you much feedback in terms of anything moving or lights turning on. So what we're going to need to do to discover if we have this functioning the way we want it to do is use a multimeter. All right, so let's go back over here and see what we're looking for. First thing that we're looking for is total resistance, and I've already shown you how to discover the total resistance in a series circuit. It functions identically in a parallel circuit that we want to make sure that our multimeter is connected in series to our power supply so that we can check our total resistance. Now, where it gets a little different is our amperage leaving the battery. So let's go over here and let's grab a multimeter. Cool. And I'm going to place this over here. And what I'm actually going to do is I am going to, I'll move my resistor down and out over here. May seem a little strange, but we'll get there. Now, in measuring amperage, what we have to do, I'm going to switch this over to amperage, we need to wire this in series, which means our output of our electricity over here needs to go into the input of our multimeter. So this is going to go in our positive, and then this one is going to go out into the first part of our resistor, and then our resistor will return back to the same spot where it was. So now this is wired in series with our multimeter. I do want to keep this out over here so that I don't actually throw any parallel circuits or short circuits in there. Now I can hit start, and I can get the value of 31.9 milliamps. 31.9 milliamps is what we're looking for, and it's looking pretty good. So we have got that much amperage that is going into our first resistor. All right, now to find the other values, we're gonna have to throw it going into this one and this one over here. We do already have the milliamps, all of the values right here, because it's shown on our power supply, so that one's kind of a gimme. So really what we just found was the amperage leaving the battery. I really should change that to, I'm gonna change it right now, PS, which means power supply. There we go. Now we've got our amps into resistor 1, which was at 31.9. Now we want to find all of our individual amps and add those up together and see if we can discover anything about the sum of our amps of each branch and how much amps is going into each of these resistors. All right, that's it. Thank you so much for watching. If you have any questions, please make sure that you're reaching out.